Hi, I'm Richard Bryan, CTO here at Sciemetric, and today we're going to demonstrate how the Sciemetric Edge can monitor a press-fit application. Over here we have our Sciemetric Edge system mounted to our demo press. The IP65 case can be mounted directly to the machine as shown. A single Power over Ethernet connection provides both data and power. The modules connect directly to sensors for easy installation. Here, one module connects to an encoder that measures the distance the RAM travels. Another connects to the load cell and measures the force applied. Using these two signals, we can plot a force versus distance waveform. In this demo press, we're pushing a pin with a notch into a ball with a spring. And from the waveform, we can see that there's a lot of insight into that process. When the ball touches the pin, we get an initial force. As the ball runs along the shaft, it's nice and flat. And then there's a big dip and a peak at the notch start and end. Using Sciemetric Studio, we can remotely access the system. Here we can see the live force as the press advances. Here we can see an overlay of the waveforms on top of each other. From this, we can see the repeatability of the process. Here we can see there's no peak and valley where the notch would normally be. How do we tell when there's a pass and a fail? Is we can monitor the force in different zones. Here we're monitoring for the end of the notch. We expect a force around 6 pounds. We can then plot that for all the different cycles. Each of the dots represents a different cycle or different part. We can then compute some statistics like the mean or maybe the plus minus 3 sigma, and we can determine some good upper and lower limits from that. So there you have it, a quick demonstration of how the Sciemetric Edge system can monitor a press and how you can get a credible insight using those waveforms.